Good morning. We're now going to be taking our notes on what we are just doing with our trig ratios. So our title is trig ratios, and I'm going to put in parentheses. Sometimes you'll hear people call this SOHCAHTOA because of how the ratios look. And we're going to talk a little bit more about that as well. So you already figured out some of these ratios on your own. So we're just going to write them in our notes just so we make sure we have them for later. So the first ratio we discovered was our sine ratio. And that looked like the sine of theta. And remember, your theta is your reference angle equals your opposite. So I'm going to put opposite over your hypotenuse. And I'm color coding it just so we can see this a little bit easier. You don't have to color code it. So what that means for our sine ratio is, say we have a triangle. Remember, these all have to be right angles. And this is our reference angle. Our opposite is, if we cover this up, it's the side we do not touch. That's our opposite. I'm going to put O. And our hypotenuse is always the side that our right angle points at. So our sine, we're working with the side opposite and hypotenuse. The next one we learned about was our cosine. And what that looks like is, it looks like cos for cosine of theta equals, so that was so, this is ka, so it will be our adjacent over our hypotenuse. And again, say we have that right triangle. Our reference angle is this one. Our hypotenuse, we find it whatever our right angle is pointing at. Our adjacent, if we touch our reference angle, is the one that it's touching. So our adjacent. And remember, our reference angle always touches our hypotenuse and our adjacent. So it's important to label our hypotenuse first. The very last trig ratio that we discovered already is our tangent. And that looks like tan of theta, remember our reference angle, equals, this would be the TOA part. So it's our opposite over our adjacent. So our OA. So if I had my right triangle, this is my reference angle, this is my right angle. My opposite, I cover this up, it's what it does not hit. My adjacent, it's what it hits that is not my hypotenuse. So those are the three different ratios that we've already discovered and we played around with yesterday. So yesterday, we were working with using the trig table and trying to figure this out. There's an easier way. So let's figure out what that easier way is. So example 1, say we have this right triangle here, where our reference angle is here, it's 60, then we have a 20, and we have an, oops, you can't see that, sorry. And we have an x. So we're trying to solve what is x. Well, I'm going to label my triangle first. That's always the first step to make it, what am I playing with? So my right angle's here, so this is my h, my hypotenuse. I'm going to cover my reference angle. My opposite is what it does not touch, and my adjacent is what it does touch. So in this triangle, I know my reference angle is 60. I know my hypotenuse is 20 because it tells me right here. And lastly, I know that my adjacent is x. So we're working with a. So out of SOHCAHTOA, this is going to be my cosine. So normally when we've done that, we've looked at the trig table, be like, okay, cosine, there's 60, what does that equal? There's a way you can do this with your calculator. So I'm gonna first set up my equation. I have my cosine of 60 equals, so cosine is adjacent over hypotenuse, so 20. So I want to know what cosine of 60 is. The way we can do this is by using our Desmos calculator. And you want to use your Desmos calculator because, again, your phones can be a little weird about this. So when you're looking at your Desmos calculator, look, there's my sine, cosine, and tangent, all right there. So I'm looking for cosine of 60. And it gives that to me right there. It's 0.5. So I'm going to go back to my notes and I'm going to write, instead of cosine of 60, I'm going to write 0.5. So I know 0.5 equals x over 20. Now we can do like what we were doing yesterday. We can set up that proportion. And because they're equal to each other, we can cross multiply and solve. So in this case, I have 1 times x, which gives me x. And then I have 0.5 times 20. So I'll put 0.5 times 20 into my calculator, and that would give me x equals 10. So we just found this missing side was 10. And that was a whole lot easier than that annoying trig table. Let's try it one more time. Let's do one last example. So for example 2, say we have another triangle, and we know it's a right triangle because of there. Our angle is 65. We know that this side is x, and this side is 24. As always, I'm going to start by labeling everything. All right, across from my right angle is my hypotenuse. I'm going to cover my reference angle. The opposite is what it doesn't touch. And then my adjacent is right next to it. So the information that I'm given, my theta, my reference angle is 65. I'm also given my opposite, which is 24. And I'm given my adjacent, which is x. So in this case, we have OA, which is our tangent. And we already know how to set this all up. So our tangent of theta equals opposite over adjacent. So tangent, my theta is 65, equals my opposite is 24, divided by my adjacent, which is x. Again, instead of going and looking at our trig table, we can now use Desmos. So I'm going to go back to my Desmos calculator, and I'm going to figure this out. So I'm working with the tangent of 65, and it gives me this really long number. You don't have to write that entire number down. You can just write 2.14. We can use 2 decimal places. We don't need to use all those decimal places. So I go back, I wrote 2.14 equals that 24 over x. We can set up our proportion again. Remember, we can put this over 1. I have 2.14 x equals 24. And now I solve. And to solve, I want to get my x alone. So that means what I want to do is I want to divide each side by 2.14. And I'll get x equals 11.21. And remember, you only need 2 decimal places. So we're basically doing what we were doing yesterday, using those ratios we found, and we're using a calculator instead of a ratio table. So we're going to go to a class kick now to do some practice. Make sure you're asking if you have any questions.